We have more talky talk. We have Noah Kantrowitz, who is going to be speaking about small footprint ETL. Please clap.
Thank you very much. Hi there, I'm Noah Kantrowitz. I'm an SRE at Geomagical Labs. We do computer vision and augmented reality stuff for IKEA. And I'm here to talk about building small footprint ETL systems, as Katie so succinctly said, using Django in particular. But I'm not here to talk about work. For this talk, I'm going to use one of my side projects, Farm RPG. It's a free online web and mobile game, and more important for our needs, it has a lot of fun data, and I don't have to run this past a million lawyers. If you're not a big gamer, don't worry. The big thing to understand is that games tend to have highly interconnected data. Items drop from monsters, and they're used in recipes, and recipes come from quests, etc., etc. In SQL terms, this looks like every table has at least one foreign key, usually 3 or 4. As much more of a web structure than you'd have in a normal REST application. And this isn't really part of the main topic, but in case anyone's wondering, did he really spend a year building a ETL system for a free internet game? Yes, I did, because it was fun, and it's a great way to learn these kinds of tools, many of which I now use at my day job. Big shout out to fun side projects where you can move at your own speed, and no one worries if you are down for a week. Anyway, moving on. So this talks about ETL. What does that even mean? The core is quite literal. Extract data from somewhere, run it through some kind of transformation, and load it into a database. Not every ETL is a web scraper, but the two are very similar, so we can kind of think of them in the same terms. Maybe instead of an internet website, you're scraping an internal API, or maybe it's a database instead of HTTP, but they're all sort of the same structure. If you think web scraper, you're probably in the right ballpark. To touch on it real briefly, a lot of very fancy folks have been thought leadering about ELT instead of ETL. It's the same core idea, but instead of storing the transformed data, first you store the raw data so you can retransform it later if you need to. If that's a feature that you need, by all means pursue it. If your raw data is very big though, that's going to balloon your complexity and your storage requirements, and since we're here to talk about small systems, I don't think this is for us. And also, because we are talking about scraping, I would be remiss if I did not remind everyone that hostile scraping is generally against the terms and conditions of websites. Make sure you have permission before you scrape things, any website, API, or data source that you don't own. If you have questions about what is allowed, please talk to the owner or a trusted legal professional, or both. But all right, scrapers aren't all of ETL. We need the T and the L too. The transforms in many of these systems are going to have 2 steps. First, you're going to want to parse stuff into structured data. If you're lucky in simple cases, this is JSON.loads. If you're not lucky, it's going to be something ugly with beautiful soup, or a binary parser, or who knows what. Then we need to take that structured data and mold it into a form that's going to be more useful for our queries later. This can take the form of something like SQL normalization or denormalization, meaning breaking things apart into smaller models or gluing them together into bigger models, or more mundane stuff like just renaming fields or combining multiple data sources into a single model, stuff like that. The transforms can also sometimes be doing data aggregation at transform time. We'll talk about this a little bit more later and some of the trade-offs in this, but if you're being really rigorous about what ETL means, then the transform would also be doing data collapse and aggregation as well. But we also need to talk about the L then. In that case, it's mostly going to be the Django ORM, which I assume most people here probably know how to use. You could use more complex stuff like Django REST Framework serializers or Pydantic, but in most cases, it's going to be something along those lines. Async in Django has been a long journey, and that journey isn't over yet, but Async Django is great, and you can use it today for real production applications. I'm going to touch a little bit more on some of the limitations later, but the overall top line thing to know is that you can really use this. I highly recommend it. Why use Async Django as the basis for an ETL system? It lets us keep everything in one code base. In most ETL systems, they have a fairly well-deserved reputation for being finicky tools. One system falls out of sync with another, and then the whole pipeline locks up until some sad on-call engineer gets paged to come out and fix it. Having fewer services means that we have fewer things that can go wrong, and when they do go wrong, we have simpler solutions for them. Here, we're probably only going to have 2 things, Django and Postgres. And if Django breaks, restart Django, and we're back in business. Also, having things inside one service makes it a lot easier to move them between different deployment tools, infrastructure providers, and it makes local development a whole lot easier. Microservices have been the cool way to do things for a really long time now, and they are certainly useful when projects get big and they cross team boundaries, but we're doing small. Small doesn't need microservices. You save a lot on the organizational complexity, on the infrastructure complexity. Don't worry about it, embrace the monolith. Thank you. Lots of talks, as well as the Django documentation, have covered the basics of starting an async app. Starting with 4.2, it's also basically the same as starting any Django app. You build your Django project, you start the first app, and then you start adding views. When you add the view, you decorate it as async, and that's it. You've got yourself an Async Django project. All of the core middleware is async compatible, so you only have to worry about middleware if you start adding custom stuff. And even if you have a project that is adding non-async compatible middleware, Django will adapt it for you, though at a performance cost. One thing Django doesn't currently include is an async-compatible web server. We heard a little bit of this in the last talk as well. Fortunately, the community has several for us to pick from. I personally like Unicorn. It has the same sort of reload on change development flow as the core run server development server. And you can use it in production if you just throw an extra couple flags on there, turn on the access logging, turn on TLS, stuff like that. But you can use the same project or the same server in both scenarios. For any ETL system, we're going to need background tasks. The normal Django way to do background tasks is celery and celery beat. But that's a whole big set of things to run. You need to run all the celery daemons, and then a broker, maybe a result store. I don't really want to do that anymore, at least if I can help it. A simpler solution is cron with custom management commands, but I think we can do even better. One big advantage of an async system is that we can spawn additional background tasks to run concurrently inside the web application, so let's do that. The core of any looping task in async Python is going to look something like this. Run the extractor function, sleep, repeat. To integrate this with Django, though, we need to hook it into the server startup process. The easiest way to do that is with the ready callback in app configs. So we want to launch our async task in the background while Django is initializing, and then let Django continue initializing as the server starts up, all of our code loads. Our stuff will just be running in the background, firing off every 30 seconds or whatever we told it to. Create task does exactly this thing that we're looking for. But we do need to talk about some of the downsides as well. With Celery RabbitMQ, we have a much more durable system. If a task gets accepted by the queue into Celery, it's going to run at least once no matter what, barring any really weird bugs. But with this, if something crashes, it's just gone. Okay, well, we can add exception handling, we can add retries, but still, if our process crashes completely, again, it's just no longer there. But this is usually okay in ETL systems. If we miss a scrape 1 hour, we'll get it the next hour. No worries. As long as each scrape is bringing in more than its interval worth of data, so if you scrape every hour, if every scrape is bringing in more than an hour of data, you've got a buffer for failure. This basically builds in the fault tolerance for you. In cases where you can't do that, you can also build specific models to track the status of tasks, just like we would have with RabbitMQ. So as an example, rather than having a background task for sending an email, we can instead store a database row for each pending email. We have a looping task that every few minutes will go through and try to send everything that is pending. When they succeed, it'll get flushed out of the database. And if not, it'll get retried. This gives us a similar level of safety to RabbitMQ. As long as something gets into that table, it will be tried at least once. This is more work, though, so always decide, you have to weigh the pros and cons of how much failure tolerance you want in each sort of piece of this system. But okay, back to async stuff. The general rule of the async ORM is any method that would talk to the database is prefixed with an A. A get, a first, a save, a update. If you ever miss an A and call the synchronous method in an async context, Django will raise an exception to remind you, hey, you really need to call the async version of this. So don't worry too much about that. There are two big limitations left in the async ORM. Transactions don't work in async code, and queries can't overlap. Talk about the second one first. The lack of overlap is mostly an internal detail. So you can run multiple concurrent queries at the async IO level. You can set up an async gather, whatever you want to do with it. But from the database's point of view, it's going to see those queries sequentially because they are run on a single background worker thread. The end result of this is that you do not yet get a performance benefit from running multiple SQL queries in parallel. Async transactions require a little bit more complexity than usual. So if we just naively did transactions in async code, we run the risk of multiple database queries getting interleaved into the transaction. So we have to pull it all into one synchronous block and run it using ASCII-ref's sync to async helper. This is definitely something the Django team is looking to improve. In very recent releases of some of the database library, the underlying database libraries like PsychoPG3, we've started seeing true async support. That should open a lot of doors for better support in the async ORM. Because fetching from web servers is such a common extractor, you will very likely need an async-compatible HTTP client. My recommendation is HTTPX. It's got a really simple API. It's got great testing support via another package called respex, and it's generally going to be really familiar to anyone that's used requests before. There's another one available called AIO HTTP. It has better sort of raw HTTP performance, but it doesn't support HTTP2, so that kind of negates the benefit of being faster. Also, unlike the ORM, both of these can fully overlap requests. So you can speed up fetching by running multiple gets or posts or whatever in parallel, though of course, make sure that you do not overload the server that is on the other side of things. I know showing code on slides is a bit questionable, but I want to go through some examples from my case study project to show you just how simple this can really be in practice. So this is the most basic version of ETL in Django. Make an HTTP request and then throw things into a database. We wrap this using that looping call helper that we saw before, and congrats, that's a mini ETL system. And maybe this is enough for you. I have plenty of things in this ETL for the Farm RPG project that look exactly like this. Maybe with a little bit more error handling, but it doesn't fit on the slide. But maybe you want to make things more complex. The nice thing about this being in code is that rather than being built out of dozens of different microservice config files, we can adapt, adjust, and improve it really easily. Another level up of complexity, for example, would be using Django REST framework to parse out the incoming data. This is really useful if you're getting back deeply nested data that contains multiple sub-objects and you want to parse those into different tables. DRF can handle that for you. Another thing to note, DRF doesn't handle async on its own yet, but sync to async has us covered. Another really common pattern in a lot of ETL systems is wanting to clean up values in the database that no longer exist upstream. So here's a really simple and honestly not very scalable version of that. This will work fine up to a few thousand rows. After that point, it gets more complicated, wouldn't really fit on a slide anymore. But for smaller stuff, this is great. This is all you need for please keep me in sync with an upstream server. But all right, setting things up in ready callbacks is a great trick, and now you know that. But sometimes we want something a little bit simpler, something more like Celery's task decorator. Unfortunately, Django has a helper method for this. It is called autodiscover modules. It is a little bit complex to use, but once you know how to use it, it is great. So it all starts with you need a field somewhere called _registry. It must be called exactly _registry. You then pass to autodiscover modules the submodule inside each app that you want to look for and the place that the _registry object exists. It will iterate over all of your Django apps, look for that submodule, and make sure that even if there are loading errors, it does not corrupt the registry. So if we want to use this, we can make a decorator, like we show here, that adds things to the registry, and we can make a single ready callback that loops through the registry and calls create task. And boom, we've got exactly the same thing as Celery's @task decorator. Having a loop that runs every 30 seconds is really good for some cases, and maybe we could make that 60 seconds or 100 seconds or however many seconds we need, but sometimes we want more complex scheduling, something like we'd get from cron. Fortunately, there is a fantastic library for this. It is called Croniter, and it handles all of the math around timing. All you need to do is track for each task the cron spec, the string of ** whatever, and the last runtime for the task. You can store that in a database model, you can store it in memory, whatever you want. Make a single ready callback that runs, it loops every second or every minute, checks, it passes the cron spec and the last runtime into Croniter. It'll tell you the next runtime that is calculated for that cron spec. If that's in the past, run a new version and update the last runtime for it. Boom, you've got a simple cron system. This does mean duplicating some logic that a real cron system or Celery Beat would get you for free, but in practice, this is about 10 lines of code and it saves you a ton of organizational complexity. ETL is an acronym, technically only covers the ingestion, but really if we are doing this, we probably want to do something with the data, and that thing is usually querying it. Now, those could be SQL queries, but again, probably all of you know how to use the ORM already, at least to a basic extent, so let's look at something a little bit more fun. I want to talk about GraphQL, but first I have to, again, do some disclaimers. GraphQL does not scale. It is phenomenal for small-scale systems. I love it, and I will talk about why, but it is difficult, verging on impossible to get good performance out of it when you are dealing with a large-scale system. If your queries are super cache-friendly, that can be a solution, but otherwise, beware the dragons. I can't possibly go over everything that GraphQL includes, because that's a whole nother conference talk, but the really quick version, GraphQL queries take a set of nested fields that you would like to retrieve. Usually there's going to be a top-level field, which is the equivalent of a table in SQL, and then you give it some filters if you don't want to get all the objects, and then the fields inside that object that you would like to retrieve. The key here is that that can be nested. So you're not just asking for the columns on one table, you can recurse through to other tables. In Django terms, this means that we can look at either columns or foreign keys, many-to-manys, or reverse managers as fields. So here's an example. If GraphQL has all these sharp downsides, why do I like it at all? It is super cool for deeply interlinked data. So this is a GraphQL query that is looking at 3 different SQL tables: items, quests, and a through table between them. So we want to get name, image, and value for all items, and then for every item, look at all of the quests that use it, get the title, image, and text of that quest, as well as the quantity used in that quest. And we can do all of that in one generic query. We could, of course, make an API endpoint for this. We could write some ORM code, and it would be fairly simple. Like doing this in a Django view, not a big deal. But the idea of GraphQL is, what if I don't want to write a dedicated view for every type of query I want to run? We're going to make some trade-offs. There are performance issues, as I keep mentioning, but it's a balance. You know, we don't have to let the clients deal with all of the join data or give them too much information. But at the cost of it will be less performant than a handwritten query. But in return, we get a single view that can answer basically any question that we want to ask of our data. Other than large data sets, though, there's 2 other major places to avoid GraphQL. So one is if you want to answer numeric queries, and the other is poorly linked data. On the numeric queries, GraphQL gives you lots of stuff to control which fields are included, as we just saw, but what it doesn't have is SQL's numeric aggregation support. So for example, I could say, give me the value of all items of type foo. Super easy query. What I cannot do is tell it, give me the average value of all of those. You'd have to compute that client side. So if we loop back to talking about the transforms, this is where you might want to instead pre-calculate those during the transform process, shove them in their own database model, say average value for type foo is 5. And then you can expose that model through GraphQL, use that instead. For disconnected tables, that would be things where there's just not a lot of foreign keys, there's not a lot of links between the tables, so GraphQL is not really getting you anything. Like, sure, you can use it, but there's way easier ways to build generic views for a single table. Don't burden yourself with this for that. The best tool I found for GraphQL and Django is Strawberry. Core library implements schema management and data flow, and then Strawberry Django adds adapters for loading data using the ORM and dealing with schema definitions for Django model types. You'll see some guides referencing Strawberry Django Plus, which was an enhancement library on top of these, but it has been merged back to core, so you don't need it anymore. A Strawberry schema defines the top level of the query namespace, just like a root urls.py does for HTTP. It takes a root query type, and that references other types. Those reference other types and each other, and that slowly builds out the web of what can be queried through GraphQL. A slight annoyance of Strawberry is having to restate all of our model definitions of Strawberry types, but at least the majority of things can be inferred automatically from the Django model. The only place where we need to get explicit is either implicit fields like ID or interlinks between types where we have to give it the Python type to link to. For structuring these things, I usually like to do it the same way we do with urls.py, so I keep the GraphQL types in each app, and then I import them into the big core query. GraphQL doesn't offer much in terms of data slice and dice, but there's a little bit. So filters allow relatively basic where checks. We saw an example of that before. Orders let you set the sort order of the results, although as a warning, they are buggy in the latest release of Strawberry Django, and they will absolutely wreck your query performance. And speaking of query performance, we should maybe look at what happens when you actually run some of these. So here's our simple query again. And this is what it looks like in Django Debug Toolbar. For those of you in the back who can't read this, the first line is relatively simple. It is running a select against the items table and pulling out the columns that we want. Totally normal. That second line is where we get the problem. It is querying against the quests in the through table, but with an enormous item ID in condition. And what if we add a couple more fields into our query? This gets complicated very fast. So this is running on my development server where each of these tables only has a few hundred rows. If there were 1,000,000 rows in each of these tables, you can see why this gets to be a problem. In fairness, this only took 200 milliseconds. So like, this isn't a huge problem. Even at relatively small scales, it's fine. At, you know, a couple thousand rows per table, still no problem. But watch it, be careful with it. Before we stop talking about Strawberry, one more word of warning. Their Async Django view is also currently a bit funky and gets intermittent data errors. Just use the synchronous view. Because of that thing that I mentioned before where you cannot overlap database queries, there is not actually a performance benefit, as far as I can tell, to using the Strawberry Async view. So hopefully that will be fixed soon, though. All right. Back to ETL stuff. A particular place where ETL and GraphQL combine really well is static site generators. Gatsby has deep native support for it, and Pelican allows you to slot this in really easily as an HTTP data source. So you can set up your static site generator, set up a build running, say, every hour or every day in your CI system of choice, and you've got a really easy way to build dashboards for your data. And another really useful feature of GraphQL is making queries and listening to live updates. So with your dashboards, this lets you immediately slot in automatic updates to your graphs without a very big code footprint. For this to work in Strawberry, you do need channels. Because we are only targeting a small server that's running inside a single process, we can use the in-memory channel layer, although you can also use channels Postgres if you would like. Check the Strawberry docs. You've got to make some config tweaks for this to work properly. All right, GraphQL is certainly useful and interesting, but it's not very fun. What kind of weird and wonderful stuff can we do with our little ETL server? Integrating a chatbot's fun, right? So the core of the integration is the same as we saw with ETL tasks. This is the same general structure you're going to use for plugging anything in to Async Django. You make a Django app, you spawn something from the ready callback, and you go. A quick note, when you are reading the docs for any async library, make sure that you know the difference between the blocking run the thing function and the underlying async task. So what you're going to find in the tutorials for most async libraries is something that starts an event loop and blocks forever. We don't want that. We're running an async server. We've already got an event loop going. So make sure that you're using the correct one. In the case of Discord Py, it's called client.start. Every library is going to call these different things, but read the docs very carefully or you're going to have weird, mysterious failures. All right, but with those basics in place, we can make a chatbot that can reach into our ETL data inside Django and run things like dynamic queries based on chat input. We've got the full power of the ORM here. We can pull in any other libraries that we want, all kinds of fun stuff. We can also use it for logging and notifications too, or we could combine it with that cron pattern that we saw before and use this for sending, say, nightly reports to a chat channel. But chatbots are old news. What if we want to SSH into our ETL server? Not into the server it's running on, into the server itself. Async SSH contains a full async compatible SSH server implementation. Is this actually useful? Probably not, but maybe there's an edge case where you could justify this. And then for some of my projects, I go all the way into the you couldn't justify this for a work project. Talking down to hardware, I have a Stream Deck controller that is async compatible and is a lot of fun to play with these things. And I have a lot of, as I mentioned, I work for IKEA, so I have a lot of IKEA IoT devices, and one of the ETL systems in my house can automatically twiddle those. This is silly, it's just for fun, but cool. All right, back to reality. I spent a lot of time singing the praises of small systems, and I will continue to do so, but what if your system starts out small and then grows? Django has you covered. One common problem is there just being too much data to transform and load in a single process. This is going to come up where your pre-transform data is huge and post-transform is very small. It's getting reduced, compressed, whatever it is, so that fitting all of the pre-transformed data in memory at once is really hard. So, simple solution here, shard your ingest. If you have multiple URLs, you can divvy them up, give every server an ID, and only process the matching ones on the matching server. End of problem. Sharded systems can get really complex with hash rings and vector clocks, but as I keep saying, start simple, build what you need. A fairly common thing for transforms in an ETL system to want to do is number crunching. Working with CPU-bound Python is about 4 talks on its own, but the really short version, if the call is something that drops the GIL, like NumPy or PyTorch, you can use sync to async with thread sensitive set to false. Under the hood, that'll move it into a background thread where it can chew up CPU to its heart's content. Eventually it'll finish, and then it'll transfer control back to your async function. If it is something that does not drop the GIL, the options are a little bit more limited. You'll want to look at either the process pool executor from the futures library or AIO multiprocess, which is an async wrapper around multiprocessing. And if your needs grow beyond all of this, the big tools are still right there. You can still use them. Maybe you swap your homegrown sharded loader for some Hadoop and Hive. You've got to rewrite a couple of Django ORM queries into PyHive, but the rest of your code keeps on trucking. So to recap what we've talked about here, ETL systems let us move data around, pull out the most important bits we need, Async Django isn't perfect, but it's very usable, and it's great for building small-scale ETL systems. GraphQL pairs well with both of them, and as a generic query interface, it can give us very easy queries with some performance issues at scale. Async Python's a lot of fun libraries to add, and there is value in starting small and simple, letting your tool grow with its use cases rather than investing in massive complexity up front. Thank you very much. Any questions?
I was going to offer to just give the mic directly to Russell, but that's fine.
A little bit off topic maybe, but do you have any advice for deploying such things?
I am a developer of Kubernetes, so I am obviously heavily biased towards it. It is my weapon of choice for most things.
Is it a bit heavyweight for small ETL?
So the problem with Kubernetes is if it was the only thing you were doing in Kubernetes, absolutely. Extreme overkill, way too much to learn. So this thing that we've been looking at is actually deployed in Kubernetes on a small hosting company that gives me a little mini server that runs K3s. But it's really easy for me because I know all of it. If your team doesn't and you are learning it from scratch, again, dramatic overkill. The difficult thing is that finding places that are compatible with long-running processes is difficult. This is not the model of things like, say, Cloud Run or Lambda, where they want to control the event loop structure for you. You can make it work with those, though, and certainly if you can, I highly recommend it.
Hands. There you go.
You very subtly dropped a reference to PEP 703 and then didn't mention it. Can you mention it now? What impact is PEP 703 going to have on those sort of optimization strategies?
That's a very good question. Stay tuned. So PEP 703 is Python without a GIL. This is very exciting to a lot of people, myself included, but it has not yet been actually accepted, so I don't know. Has it?
Yes, it has.
When?
Steering committee about 2 weeks ago.
Steering committee said they are going to accept it. They have not accepted it. As they have said that with some changes they will accept it, but I do not yet know what those changes will be because they have not accepted it yet. So it will be accepted mostly as is. The intent is that there will be a compile time flag that you can set that will build Python without the GIL. This means that if you just go into a standard like Ubuntu server and you run Python, you're going to get Python with the GIL, the same as we've always had. It will be a build time thing. You will need to use a specialized build of Python and probably specialized libraries to some extent. But you will get all of the benefits of real threading like we have had in, say, Java or Go. Exactly how that will end up working is still a large open question, though.
Hi. When you were talking about web scraping, you mentioned not breaking the terms and conditions of a website.
Yes.
Are you what are the legal implications of breaking the terms and conditions, except not being allowed to access to the website anymore?
I really cannot answer that question. I am sorry. I would feel uncomfortable answering it. If the accent doesn't give it away, I am not from Australia. I super do not know your computer laws here, and I would feel very poorly equipped to opine about things. Speak to a legal professional at your company or a friend. That person should be more knowledgeable than me.
We have time for one more question. No?
Thank you very much, everybody.
Yay, clap.